Here's another one. Here we have to distribute first, and then we'll simplify each side of the equation separately. Pause your video, try it on your own, and see if you can solve for m. First, I'm going to distribute. So I'll have 5m minus 15, because 5 times negative 3 is negative 15, minus 7m on the left is less than or equal to. When I distribute the 4, I have 4m, and 4 times negative 3 is a negative 12 plus 9. Now I can combine like terms on each side separately. So 5m minus 7m is negative 2m, still have my negative 15. On the right-hand side, negative 12 plus 9 is negative 3, so 4m minus 3 on the right. Now I want to get the m term by itself. I like to keep my variables positive, so I'm going to add 2m to both sides. Negative 2m plus 2m is 0. That leaves me negative 15 on the left, and 4m plus 2m is 6m minus 3 on the right. Now I'm going to add 3 to both sides to get the variable term by itself. Negative 3 plus 3 is 0. Negative 15 plus 3 is negative 12. Negative 12 is less than or equal to 6m. Now I need to get the m by itself, so I'm going to divide both sides by 6. 6 over 6 is 1. Negative 12 divided by 6 is negative 2 is less than m. Notice I divided by a positive number. I didn't flip the inequality. But again, my m is on the right, and I like it when my m is on the left so I can go straight to the number line. So I'm going to flip the inequality so the variable's on the left. That means I write it as m is greater than or equal to negative 2. I flip the inequality as well. So my inequality is m is greater than or equal to negative 2. Set builder notation, m, such that m is greater than or equal to negative 2 in curly brackets. When I put it on the number line, I start with negative 2. Notice I'm going to use a square bracket because I've got an equal in my inequality, and I fill in to the right, shade into the right. Make sure on your graphs you've shaded in well so I can tell it apart from the region that's not shaded. My interval notation, I start with the square bracket, negative 2, and I go clear to the right to infinity with an open symbol on that side. Again, notice my square bracket lines up on both a number line and an interval notation, and both of them go to infinity on the right. I can check my solution. Let's try negative 2. If I plug in negative 2 and do the math, that negative 2 minus 3 is a negative 5. Negative 5 times 5 is negative 25. Negative 7 times negative 2 is 14. On the right-hand side, negative 2 minus 3 is negative 5. Negative 5 times 4 is negative 20. When we do the rest of the math, we get negative 25 plus 14 is negative 11. On the right-hand side, we have negative 20 plus 9. That's also a negative 11. Negative 11 is less than or equal to negative 11. True statement. You might also try 0. That's in our shaded region. When you do the math, you should get negative 15 is less than or equal to negative 3. That's true. So that works. You might try a number from the side of the graph that's not shaded to see if you get a false statement like we would expect. Here's another one. Again, pause the video, do the math, start with distribution, watch your signs. You've got to distribute that negative sign on the right. Okay, let's do the math. First I distribute. 4 times x is 4x. 4 times negative 1 is negative 4. On the right-hand side, you might remember to write yourself in a 1 in front of the parentheses, because remember, when it's not there, we can write it in. That means I've got negative 1 times 2x, which is negative 2x, and negative 1 times a plus 1, which is a negative 1. Now we can simplify each side. 4x minus 3x is 1x minus the 4 on the left-hand side. On the right-hand side, negative 5 minus 1 is negative 6 minus the 2x. Now I want to get my variable term by itself. I want to keep my variables positive, so I'm going to add 2x to both sides. Negative 2x plus 2x is 0. On the left-hand side, I've got x plus 2x is 3x, minus 4 is greater than negative 6. Now I want to get the variable term by itself, so I'm going to add 4 to both sides. Negative 4 plus 4 is 0. That leaves me 3x on the left is greater than negative 6 plus 4 is negative 2 on the right. To get the x by itself, I'm going to divide both sides by 3. 3 over 3 is 1, so I've got x on the left is greater than negative 2 over 3 on the right. I didn't flip my inequality because I divided by a positive number. My inequality is x is greater than negative 2/3. In set builder notation, it's x such that x is greater than negative 2/3. Put that in curly brackets. To transfer it to the number line, I'm going to start at negative 2/3. Negative 2/3 is between 0 and negative 1. I'm going to start with an open symbol because I don't have an equal in my inequality, and because my variable's on the left, I can fill in the direction of that inequality. I fill in to the right. I start my interval with this same open symbol that I've got on my number line. Start with negative 2/3 and go towards the right to infinity. Infinity always has an open symbol. Notice that the open symbol on my number line lines up with the open symbol on my interval notation. Again, you can check your solution. I've done the math here for you. I've plugged in negative 2/3 for x. You should be able to follow the math. In a couple of places I've had to create equivalent fractions with similar denominators, and when you get down to the end, you have negative 14 on one side, negative 14 on the other side. I know I at least have the right solution, but negative 14 is not greater than negative 14. That's why I used an open symbol on the number line and in the interval notation. It's not greater than, it is equal to. So the statement is false at the end, but the false tells us that our math was correct because negative 14/3 is the same as negative 14/3 on both sides of the equation. Three-part inequalities, these look a little bit different. We never do equations like this. We never put two equal signs in an equation, but we do put two inequalities to create three-part inequalities. We're going to do the same thing though. We're going to add, subtract, multiply, or divide to all parts of the inequality. You want to end by making sure that the smallest number is on the left. Let's show you what I mean. 3 is less than, x plus 2 is less than or equal to 4. I want to get the x by itself. To do that, I'm going to subtract 2, but I've got to subtract 2 from all three parts of the inequality. Plus 2 minus 2 is 0 when I do the rest of the math. 3 minus 2 is 1 on the left. I've got my x by itself in the middle is less than or equal to 2 on the right. 4 minus 2 is 2. That's my solution written in inequality form. Notice that the smallest number is on the left, just like on a number line. That's what I want it to be. I want the smallest number on the left. So my inequality is 1 is less than x is less than or equal to 2. Set builder notation would say that any value of x works such that 1 is less than x is less than or equal to 2. Make sure you put curly brackets around your set builder notation. We can transfer this to the number line. We're going to start at 1. That's going to be an open bracket. X is any value in the middle between 1 and 2. Notice that 2 has a closed bracket because there's an equal sign on that side of the inequality. Any number between that open bracket and that closed bracket would make a true statement here. If we picked 1.5, that falls between 1 and 2. 1 is less than 1.5, and 1.5 is less than or equal to 2. Makes a true statement. Our interval notation is going to line up with a number line. We start with the open symbol and start at 1. We go up to 2, and we've got the closed bracket on that end. Notice that those open and closed brackets line up. Here's another one. Negative 7 is less than 5 fourths x minus 1 is less than or equal to negative 1. We want to get the x by itself. To start with, I want to get the x term by itself. So I'm going to add 1 to all 3 parts of the inequality. Negative 7 plus 1 is negative 6. My negative 1 plus 1 is 0, so in the middle I've just got 5/4 x. And negative 1 plus 1 leaves me a 0 on the right. I didn't change any of my inequalities. Now, to get the x by itself, it's multiplied by 5/4 right now, so I'm going to multiply by the reciprocal. Because I know that when I multiply a fraction by its reciprocal, I have 1. But I've got to multiply all three parts of the inequality by 4/5. So let's do the math. On the left, negative 6 over 1. So I multiply across the top, get 4 times negative 6 is negative 24. 5 times 1 is 5 on the bottom. So negative 24 over 5 on the left. In the middle, I just have an x. And on the right, 0 times 4/5 is still 0. Notice my smallest number is on the left, just like on a number line. That's what I want, so that's my solution. That's my inequality. Negative 24 over 5 is less than x, is less than or equal to 0. In set builder notation, I add that x out front with the pipe, x such that any x is, you can see how I've got it written. Negative 24/5 is less than x, is less than or equal to 0. Don't forget the curly brackets. To represent the solution on a number line, I start with negative 24/5. Well, that's it's smaller than negative 4, it's bigger than negative 5. So I'm going to put an open symbol out about where that is, negative 24/5. I go all the way up to 0 with a closed symbol because I've got an equal sign on my inequality on the 0 end of that inequality. My interval notation is going to line up with my number line. I start with that open bracket. Start with a negative 24 over 5. Go up to 0, and I have a closed bracket. Both sides of the number line match up with both sides of my interval notation. Here's another one. Pause the video and see if you can do this one by yourself. The first step is to get the variable term by itself. So I'm going to add 1 to all 3 parts. Negative 1 plus 1 is 0. Negative 4 plus 1 is negative 3. I've got negative 3 over 2x in the middle and 0 plus 1 on the right. Now I've got to get the x by itself. To do that, I'm going to multiply by the reciprocal again. The reciprocal of negative 3/2 is negative 2/3. If I do that, I've got to multiply all three parts of the inequality by the same thing, negative 2/3. In the middle, negative 2/3 times negative 3/2 leaves me a positive 1. On the left-hand side, if it helps, put your negative 3 over a 1, multiply across the top and across the bottom. A negative times a negative is a positive. I've got 6 over 3, which simplifies to a 2 on the left. And on the right, 1 times negative 2/3 is negative 2/3. Remember that when you multiply or divide by a negative number, you have to reverse the inequality symbols. Notice I wrote the inequality symbols reversed. The less than became a greater than, and the less than or equal to became a greater than or equal to. Now, our smallest number needs to be on the left, but the biggest number is on the left. So we need to reverse the whole inequality. I'm going to write negative 2/3 on the left, the 2 on the right. And when I do that, I have to flip the inequality symbols again. But notice that the 2 still has the one that does not have an equal sign by it, and the negative 2/3 has the one that has an equal sign. The directions of the inequalities have switched because we switched the direction of our whole inequality. So our solution, written in inequality form, is negative 2/3 is less than or equal to x is less than 2. You can write it in set builder notation using the curly brackets. And because we've got the smaller number on the left, we can transfer that directly to the number line. We start with negative 2/3. That's between 0 and negative 1. We start with a square bracket because we've got an equal sign in that inequality. We go up to 2. We use a close or an open bracket on that side because there's no equal on that side. Interval notation, we start with that square bracket just like the number line. Negative 2/3, comma, we go up to 2 and we end the interval notation with an open symbol just like on our number line. You could check this by picking the value 0. That's in the shaded region. You're going to have negative 4 is less than or equal to negative 3/2 times 0 minus 1 is less than 0. When you do the math, you get negative 4 is less than or equal to negative 1. That's true. And negative 1 is less than or equal to 0, is less than 0. That's true. Okay, here's one more. Pause the video. See if you can do it by yourself. To start with, I'm going to subtract negative 2 so I can get the x term by itself. Got to subtract negative 2 from all 3 parts of the inequality. Negative 6 minus 2 is negative 8. My plus 2 minus 2 is 0, so that leaves me 1/3 x in the middle, and my negative 4 minus 2 should be a negative 6. Oh, I blew that one. So change it to a negative 6. That might change some of my other numbers. I'm going to change that to an 18. I'm going to go ahead and change them while I'm here so that they're all done. 18. Okay, now I can start from the current slide. Okay, I've got that negative 6 on the right. Now it's correct. Okay, now I want to get the x by itself, so I'm going to multiply by the reciprocal. That's 3/1. 3/1 times 1/3 is 1. I've got to remember to multiply all 3 parts by 3/1. 3 times a negative 8 is negative 24. I've got an x in the middle. Negative 6 times 3 is a negative 18 on the right. This is in the correct sequence because my negative 24 is on the left. The bigger number, the negative 18, is on the right. We multiplied or divided by a positive number, so we didn't reverse the inequality. And we've got the smallest number on the left, so our inequality is already in the correct form. I write it as negative 24 is less than x, is less than or equal to 18. You can put that in set builder notation, and because the smaller number is on the left, we can go straight to the number line. Notice this number line doesn't have any numbers on it because our range is so big. So you can put tick marks to represent our negative 24 and our negative 18. From negative 24, we have an open symbol going up to a closed symbol on the negative 18 because negative 18 has an equal in the inequality. Interval notation, again, right below the number line. Start with your open symbol. Negative 24 goes up to negative 18, and it's aligned with the closed symbol. Both sides of the number line should match the sides of the interval notation. Make sure that your interval notation matches your number line. Okay, be careful with application problems. The 2 statements I've got here mean different things. 5 is more than. Remember that before, that is was an equal sign. So 5 is more than, we use the greater sign, 5 is greater than x. If it says 5 more than a number, we're adding. You have to have the is more than for the greater than symbol. If it just says 5 more than a number, it's 5 plus x. Be careful in your reading as you're reading the application problems that you're doing in your homework tonight. Finally, an application problem. Maggie has scores of 98, 86, and 88 on the first 3 tests. She wants to average at least 90 after the 4th test so she can make an A. What score must she make on the 4th test? You need to know how to compute an average to do this. To compute an average, you're going to take the sum of the scores on your test. We're going to have 4 tests by the time we're done. So we're going to add 98 and 86 and 88 and the unknown for the 4th test. And we divide by the number of scores. so we divide by 4. She wants to score at least 90, but it's okay if she scores more than 90. So we're going to put a greater than or equal to. 90 would be okay. More would be okay. So we represent at least 90 with greater than or equal to 90. Okay, you know how to solve things like this when they're equations. We want to get rid of the denominator. To do that, we're going to multiply both sides by 4 because 4 over 4 on the left is 1. We've got to remember to multiply the right-hand side by 4 also. So now you've got 98 plus 86 plus 88 plus x is greater than or equal to 90 times 4, which is 360. I think you can take it from here, but remember, when you multiply or divide by a negative number, reverse the inequality symbol. That's all you need for today. You should be able to do the homework. Have fun.